Hello everyone, welcome to another stream. Hi to Lycan, hi. As you can hear in the background, Jesse is hard at work. That's because I just finished some 3D modeling work, and you know, Jess is just doing the 3D printing for that 3D modeling. I have so many 3D prints on my desk, it is unreasonable. I'll have to clean those up. I need to find some kind of like container for all of them. I don't want to throw them away. That's because I'm a hoarder. I'm an extreme hoarder, and if I remember correctly, you can actually take this colored PLA and turn it into oil if you do it right. Hi, the Nerdo Milk. She left you. Who left you? What happened? Don't let me. Also, another thing, because yeah, I was modeling the things for do that, but at the same time I was also working on the video because multitasking. So that's also what we'll be doing today. What does it do? Well, different -1. Then on the next smaller number, we perform the same operation. So right here, we move this 50. Move this down like so, and then what we need is we need n-2. But factorial. You see, instead reminds you of factorial instead of not, because this is factorial. Yeah, that's correct. That is in fact factorial. That is the one, the only. Okay. Now the null operation will be possibly for another video. The null operation in this context. Give me this. There we go. Y coordinate copy. It feels so weird to do it in a non-parameterized way. I've just finished a big session in SolidWorks where everything had to be perfect, and it does feel really weird for it to all of a sudden be just whatever. Okay, so now you start at 1 and then you go to 0 like this. And then this, and then render animation. Hi, the Bedsig! Why? Welcome! Hi, the Rushquant as well, hi. Oh. Yeah, Jess is indeed doing the stuff. I hope the background is blurry enough, because it's kind of hard to read, maybe. I made the background specifically blurry, I added, you know, depth of field. Mathematics the program is, and I can agree the following statement is true. Funny. Okay. Well then everyone, today I have 2 different things I would like to do. Which is, first of all, this video, just work on it, like we're doing right now. And second of all, start work on another video. Wow, another video. Isn't that quite something? Hey, make it. If Timon joins, you should pretend to end the stream. Or I could just end the stream. Timon can join at best in 2 hours, if I'm not mistaken. And we don't know how long the stream will be. Yeah, how are you streaming so early? Well, I spent the entire night working, that's how. You're making video about factorials? No, not quite. I'm making video about programming languages and implementing the operation of a factorial. But the other video I want to make is a new series of videos in which I would go over every single electrical component in way too much depth. That's the series I would like to start because it's actually pretty fun the way you can describe most of the electrical components using quantum mechanics. It's really neat. It will be especially useful in the case of battery. Well, not quite quantum mechanics. We won't get that much in depth. Chemistry. Let's keep it simple-ish. And so battery will be the first one. In the case of battery, we will need to Well, I don't think we'll need to do Ohm's law. I think we'll leave that for episode number 2, which is a wire. But for the battery, we will do the reactions inside the battery. And for that, lithium... What's lithium ion? Wait, no. Potassium hydroxide, zinc, and manganese dioxide. What's that kind of battery? Battery with potassium hydroxide, manganese oxide. What's the name of that? Alkaline. There we go. That was the name of the battery. Jeez, I remembered the chemicals. I didn't remember the I didn't remember the name alkaline. Verak just to start incorrectly explaining what an integral is so we can correct you. No, we need to be a bit more specific. Because Reblax, if I would just incorrectly start explaining the integral, Reblax would catch on the bit. I would need to start explaining something like group, or just pretend to explain the manifolds. Just be like, yeah, you see, manifold is when you take a space which we call money and then we fold it on top of itself, and resulting intersections are the manifold, you know, something like that. Just spin absolute bullshit. Explaining electronics quantum mechanics, that is crazy. Not quite, not as much as you think. Quantum mechanics get a lot of rep for being complicated, but it's not as crazy as you think. Well, also depends where you draw the line. In my opinion, electron orbitals are quantum mechanics because, well, that's just a wave function. Electron orbital is just a fancy way of saying, well, I guess a less fancy way of saying wave function, which is just concept from quantum mechanics. When manifold was in engineering, but not maths. Are those different? I wouldn't know. I don't do engineering or maths. Anyway. Alkaline battery, that's what I wanted to explain. And we're gonna have a couple of... So, alkaline battery. First we're gonna have the intro as always. Then basic quick overview of the reaction. Then the next one will be first half reaction. How ions can pass, second half reaction, then a review. It shouldn't be too long. I don't want to stretch it out for no reason. No, it won't be too long. It'll be reasonable. It'll be reasonably paced. Oh, my hands are really cold and I'm just holding a hot cup of coffee. It feels really nice. I just want you all to know that. You know, life is about little pleasures. Something like holding a hot cup of coffee on a cold morning. Yeah, that's it. That's what it's all about. Manifold in engineering is a device that combines and separates fluid channels. Okay, then I suppose manifold in maths is probably different. No. Oh, that's good. Okay, so first, quick overview of the reaction. First, let's start by quickly seeing the reaction that takes place. And that is quickly taking a gander at the reaction. That reaction is this. Yup, so if time is an intelligence which is subjective, what is subjective? Wait, what? Am I missing some context? The reaction. There we go. Chemistry. So, two half reactions, of course. And then we have the overall reaction, which is the one we'll start with, actually. It'd be this. Can I just copy this? Can I really? This. Wait, why is this an S? Biochemistry. Oh, solid, right. For a second, I know. I knew it was one of the states. I just... Oh. Thank you, Jesse. Thank you, let me know. Right, there's a wait, this is liquid, correct? Or am I crazy? Because liquid was liquid and aqueous was dissolved in liquid, right? In which dissolvent is water. Oh, never mind, I am good. A lot of context and 5 pings in Chucky's. What do you mean? There isn't a single ping there. Currently cleaning. What should I put on his music? Oh, damn it, was the name of the frog guy. I don't want to open up Spotify on stream because it might start playing music and might get copyrighted. Aqueous looks like it's misspelled. Also, I mean, okay, who needs that many vowels in a row? 1, 2, 3, 4. That's 4 vowels. It starts with a U and ends with a U. I don't mean to be that guy, but that looks jamais vu. Pardon me, but that is a jamais vu if I've ever seen one. Zinc. React it with manganese dioxide, water, and in return we get zinc with 2 manganese oxide hydroxide. Wait, what? Manganese oxide. What's this? What are you? What's your name? There's no way it's manganese oxide hydroxide. Oxohydroxide. I'm sorry, it's oxohydroxide. Right. Oh wait, or is it? Oxidize manganese to ions to trivial states. Why is this a link? I want to copy that word. You suck so much. I want to copy that word. Oxohydroxide makes sense because oxo is oxygen and hydroxide. But I want to double check and triple check. Oxyhydroxide. Ah, I knew it. Shouldn't there be... There you are. There you go. Second break. There is much... Make it. Me and Timon were arguing about if his opinion, that my opinion is objectively wrong, is subjective. It devolved into us saying back to back which is objective and which is subjective. Then Timon took it to Chucky's and pinged me there. Wait, what were the arguments? I'm curious. Immoral. Immoral, listen, you're either about to get your argument completely shut down, or you're about to gain me as your ally in the argument. So you better make your case pretty good. And if you choose to tap out right now, I'll just call you a coward and ban you. So, you know. Well, I won't ban you. I'll flip a coin, and if it lands on one of the sides, then you'll get banned. So, you know. Go on. Make it, you can't this English vowels, you have Polish consonants. That's not a big deal, actually. It's not that big of a deal. They make pretty reasonable sense. So basically, a consonant in polished like this. I'm guessing that's what you mean with this little fucker on top. I don't know what it's called. This is basically like CI combined into a single letter. That's always how it works. Like you have the same thing with N. So this is actually quite reasonable. What else is there? What other letters have that? S? Fuck, I don't remember any other ones. Are there any other letters that have that? I don't remember much of the Polish language, to be honest. That's all I remembered. Maybe there are some additional ones. Z! Fucking hell, of course, Z! Fuck, yeah, that one as well. I forgot about that one. Yeah, like, that makes sense. So, 5 continents in a row. Well, yeah, you did pick a pretty messed up word, I'll give you that much. But as I mentioned, this isn't really that much of a consonant, so this is kind of like this kind of word. Except, you know, these are kind of meshed together. So yeah. Hi from... You did not fucking get struck by lightning again. You didn't. You did not. No. Black Thunder. No. No. First of all, why the fuck would you go out into the storm? Why? There was no need for that. You fucking... No. You knew. You knew about the... No. No. No, you did not. Don't go out into the storm. Don't just... You're the one person. You're the worst person. Wait, actually, what happened? Did you get into car crash or did you get struck by lightning? I want to know, because with you it could go either way. It calls to me. Yeah, it's Zeus. About to almost kill you again. Wait, was it car crash or lightning strike? Because with you, I'll never know. How does one get struck by lightning? I don't know, ask Black Thunder. Black Thunder, wait, was it lightning to car? Of course it was fucking lightning to car, because it's you. How do you get struck by lightning twice? I don't know what to say. You know what's funny? Hold on, I'm gonna show this on stream, because you know what's funny? You know what's hilarious? This is what... Hold on. What time is it right now? It's 4 AM. Okay, this is what Black Thunder... This is what Black Thunder sent 2 hours ago. This is what Black Thunder sent 2 hours ago on the Patreon chat. This is what he said 2 hours ago. 2 hours ago, this is what he sent. Okay? Fucking... Don't call gods pussy bitches, alright? This motherfucker got struck by lightning, alright? Then saw a storm, called the gods pussy bitches, went outside and got struck by fucking lightning again. Black Thunder, just, I mean, why? Why? I'm just done. I'm done. This is... No, I'm gonna add it to best comments. because it's funny. But yeah. Anyway, manganese oxyhydroxide, right, that's what we were doing. I'm pretty certain that there is this website. Which was it? Hold on. Is this manganese oxyhydroxide? I can't tell. Any chemists watching right now that could help me out? Many of my comment chat messages in your best comments folder. It's not a folder. It's a channel on Discord. How many was degree in electrical engineering? I found this new series you're working on to be really interesting. The computer science one? Yeah, I like it a lot. I like it a lot because computer science is the topic I feel most comfortable in. So I can finally talk about things I did, in fact. I have a lot of experience with it, so I like it a lot. Hi, the Tefta! Then the great thing we talk about, because I have a new idea for the next Open Masu band. Wait, next? You mean like the next version or next iteration? No, let me a sip of coffee. Okay, is it manganese oxyhydroxide? Because first let's set up the next series of animations. Yeah, it's getting a bit hard to see here, you know? It is, it really is. So let's very slowly, in a very subtle way. Next version will be a relative flexibility that wraps around the arm. Also, hi Megan. Hi Theft! Oh, this is already as blurry as it gets. Well, another thing we can do is we can just take the volume and we can make the volume darker. Yeah, we'll first need to increase this to 0.1. And actually, I also have done so. I'm sorry that I didn't get struck by lightning. Chance one is in the... Listen, don't worry. I feel like the Black Thunder functions as a effective lightning rod for everyone in this area. Stop insulting the gods. Black Thunder. Stop. Wait, what was I saying? I lost my train of thought. Oh yeah, right. Actually, you're working on the magnetic thing. I've been working on other things. As I've said in the Patreon channel right before starting the stream, I have gotten quite adequate. I wouldn't say I'm good, but I am quite adequate with SolidWorks at this point. It's actually so convenient to work with, I have to say. I like it a lot. And so to do that keeps getting more and more upgrades. In this case, what we want is we want this. Hold on, first of all, the volume. Okay, that might be a bit too extreme. That also might be a bit too extreme. We want to do it slowly. We want it to be subtle. Let's do 15, there we go. CAD is fun. It really is. And making things is just fun. Finally, I'm not just working on theory. Jeez. Well, after some time, the man just gets tired of talking about the same functions, describing some just random concept of a particle. It's exhausting. Alright, there we go. And then 0.6. I wanted to each and every single one of them to be more and more saturated with red, but saturation is exponential in this case when it comes to visibility, which means that it won't be all that visible. But this 2 and 3. The close brackets. Yeah, it's gonna be really difficult to tell what's going on. Stop making live streams, just make normal videos again. Again? Fefe, I don't mean to be that guy, but I've been streaming for the past 800 days non-stop. Before the live streams, this channel didn't even exist. This channel is younger than Child Checkups. So, unless you were here over 2 years ago, I don't think you remember what kind of videos I used to make before the streams. I love the backgrounds of animations. You mean these? As nice as they look, because they do look very nice, unfortunately that is not due to my skill. It is absolutely not. That is just pay to win. I just bought the production crate license and they just have the materials I use for backgrounds. So in this case, the background is just a plane. That's it. It's just a single plane with just a texture. Stop making videos and do 16-hour live streams every day. I could do both, you know? I work on my videos on... Okay, yes, first of all, make it. Don't yell. Your neighbors are still sleeping. But I could do both, you know? I could stream 16 hours and work on the videos. In fact, I'm already working on videos on streams right now. Right. I'm still checking if this is manganese oxyhydroxide because I just... Chemical portal. Oh, I think that was the one. I don't make it. How does one deal with schizophrenia without money? Well, depends. I imagine you talking about the schizoid personality, which I believe is a spectrum, and in that case, unless you're actively seeing things that aren't there and are having hallucinations, just interactions with people help, because then all of your delusions, because then you can differentiate between your delusions and real life. Anyway, I cannot feel my fingers. Electrotherapy. Just rest. Black Thunder, go and... I don't know. Oh, actually don't rest. I don't know. Whatever they tell you in the hospital. Just be in the hospital, for goodness sake. You just got struck by lightning. Again. If I had a nickel for every single time you've been struck by lightning, I'd have 2 nickels. Which isn't a lot, but it's weird that happened twice. Why is DuckDuckGo not your default search engine? I don't know. I'm just used to typing in DDG at this point. Will it be organic molecule? From drawing? No, I don't want from drawing. I can just type in the draw bot because before you can add atoms. Yeah, I don't want organic. I want inorganic. From picture, no, from... Oh, there we go. No, that's a number. This. Unknown compound. Is it? Is it now? Is it an unknown compound? Is it because it's a 2? It's because it's 2. There we go. This is manganese oxide hydroxide. Alright, manganese oxyhydroxide will have to be good enough. Divine Authority was... Okay. Hi, I'm new to your channel and really love your content. What do you use to make the animations for your videos? I'm so glad you asked. I use Blender. This is Blender, and that's what I use to make animations for my videos. What's rendering? Okay, let's just call it manganese oxyhydroxide. Manganese oxyhydroxides. Neat. Specifically, in the intro, I specifically stated the action. I'm overusing weld really often in my videos, and it always pisses me off. It gets annoying after a while. Found no PubChem, it's called dihydroxyoxomanganese apparently. Okay, di just means two, so it is hydroxyoxomanganese. Wait, dihydroxyoxomanganese? What? Never mind. Hydroxyoxomanganese. That is a different thing. I think? Or is it? Looks like a different thing, because right here, that's two... Yeah, that is a different thing. Right here we have... There's two molecules, so it's manganese, 2 oxygens, and a hydrogen. And right here we have manganese, 3 oxygens, and 2 hydrogens. Do not point the sky and yell, you ain't got the balls. These batteries generate electricity. It's worse than the chemical action. When it comes to electrical components, it's always better. I prefer to explain them comically in depth and understand that. Let's peel away a layer of abstraction from our battery. So, I go now. Okay, good. Go and heal up. I don't know how you heal up from lighting, but you're in a hospital. I'm guessing people that know. I searched the wrong thing and no, it's just chemistry. I searched the right thing and I couldn't find it. Do you have an extensive background in math and physics to explain these concepts well? No, but I know a guy. I don't have extensive backgrounds to explain all of these concepts well, but I do know people who do have extensive backgrounds to explain these concepts well. That's why I usually consult them when it comes to something I don't know. If there are things that I can understand, then I just research them myself. So for example, the quantum mechanics series, every single video so far I have researched myself because they were all pretty simple. But in order to understand the ket reaction, my goodness, my brain is just poisoned with chemistry. In order to understand the bracket notation better, I did ask Reblax, and Reblax, so this video, I did ask Reblax about to give me just a quick linear algebra lesson, and then I did confirm with Remco if my understanding is correct. Reblax is my maths expert, Remco is my physics expert. Hold on. Let me show you, because I'm pretty certain it was also on stream. The Reblax whiteboard is in the live channel, which means I can actually access it here. There we go. This is a simple explanation of linear algebra. Most of it is linear algebra. There are a couple of... No, most of it is linear algebra. So yeah, I don't really have an extensive understanding. However, I am a quick learner and I ask people who do have an understanding to double check my work. Well, unless it comes to computer science videos, in which case I just do have an extensive understanding because I have worked with computer science for quite a fair bit for fun. It's a hobby. It's the magic smoke inside all the electronic components that makes it work. That's true, yeah. It's wizardry all the way down. Listen, I don't mean to be that guy, but fields are just magic. Fields is just what physicists call magic. And it's always fields. It fields all the way down. Okay, battery. Battery. Can divide into 3 segments. The first... zinc was in the... No, wait. In the middle was... Because manganese oxide... potassium hydroxide was in the middle to move the oxides. Make it. Weren't you a CGI artist? Yeah, that was the job. But I had hobbies, you know? My degree in physics and math, and I feel like you explain things in such a nice and intuitive way. Thank you. Thank you. So that's really nice. Yeah, that's the main thing. I'm a generalist. I try to be as general as possible. It was potassium hydroxide in the middle, correct? If I remember correctly, because you want to move the hydroxides without moving the electrons through, which potassium hydroxide should be able to do, because it reacts on both sides. Battery is named from the alkaline electrolyte, so acidic ammonia, or zinc chloride. Otherwise, yeah. A cumulative neurotoxin? Oh no! This is a problem because for this video I wanted to make a real-life battery. I have potassium hydroxide in my chemistry cupboard. I have manganese dioxide and I have zinc. But if they're neurotoxins, that's kind of rough. That makes me want to reconsider. Can't sleep. Something about being boiled from inside out. I've been told on a couple of occasions that I serve as a good distraction. Okay, that will help. You want to work with manganese? Yeah. Also a carcinogen, isn't it? Everything is a carcinogen nowadays. Can't even eat just burnt things. Or plastic. Or burnt plastic. Into 3 segments. The first one be the manganese dioxide. Second one will be the potassium hydroxide. Third one will be the zinc. I'm pretty certain. Let's double check. Recharging of alkaline batteries? No, looking for chemistry, right? The first half reaction is zinc plus this. It gives us, yeah, so this is the one we'll end with. Nicotine carcinogen. I mean, most chemists work with dangerous materials at home, so I think if you are careful, you'll be fine. Yeah, but most chemists also have high-end safety equipment for working with those chemicals. For example, Harry from Scrub Science does work with like really, really dangerous things on a daily basis. He's been making sulfuric acid with sulfur dioxide and trioxide so many times, but at the same time he does have extremely high-end chemistry safety equipment, just in case. Chemists have ventilation, Make does not. That's another thing, yeah. I don't really have much of an open space to work in. My apartment is tiny, so we might need to not do it. Which, unfortunate, but oh well, it happens. Negative, yes, so this produces the zinc oxides and generates the electrons. This is really similar to burning. A really similar reaction, because it's kind of the same reaction, oxidation. And then the reductions what we'll start with. There's the chemists I took to the stories I have from them. I mean, okay, chemists in making do a lot of dangerous things, that is true, but I shouldn't really advertise for dangerous behavior on my channel, like irresponsible behavior. If I'm gonna advertise for irresponsible behavior, it better be with fires and, you know, things like these. Things where it's obvious that I'm doing something dangerous for the funny aspect in the video, not as a normal reaction for people to repeat. I want to make it abundantly clear that when I do something dumb and dangerous, it's dumb and dangerous. I'm working with hydrochloric acid in 6th grade and my teacher was cooking. I mean, hydrochloric acid isn't that bad. It's not that terrible to work with. The worst things are the gases. Those are the worst. Liquids, yeah, I mean, liquids, you can contain them, at least. Peak wind and ventilation stuff, yeah. You should play with electricity. It clearly works so well. People try to drink it. Why would you drink acid? Alright, 2 manganese, yeah, plus 2 waters, 2 electrons. To this. Okay. Well, then, well, will be zinc. Reason why we like to separate them into these layers is because now it's called vinegar. Why are people drinking lemon juice? So responsible. I can't believe it, I'm making a genuine chemistry video. Ew. Another thing I've heard people in the US lab were working with ferrocyanide, and one says, does anyone else smell almonds? Ooh, ferrocyanide, hold on, let me guess it. It's, is it, oh wait, what was cyanide even? It was, I remember cyanide was comically simple, it was hydrogen with something. I forgot what cyanide was. It was hydrogen with something else. It was a comically small molecule. I'm guessing ferrocyanide is just the same thing with CH. Is it CH? CN. It wasn't hydrogen. It was a nitrogen. Ah. There we go. Yeah, I remember that cyanide was comically small. I do remember that much. Just 2 atoms. Ferrocyanide is iron with 6. Okay, yeah, that makes sense. That does look quite violent. Why would you drink acids? It's depending to describe the taste of sulfuric acid. It was delicious. I didn't drink sulfuric acid. I tasted it. There's a difference. Also, it was funny. Because now we can... yeah, we won't build a battery. I don't really like the idea of working with neurotoxins, you know? You know what you should drink? Aquarita, I don't know what that is. Reaction into 3, 1, 2, well, two and two halves, two reactions. The oxidation, the reduction, and oxidation. So let's walk through them step by step. First, we have the reduction. It's a mix of nitric and hydrochloric and can dissolve stuff like gold and platinum. That does sound violent. Mix of nitric acid and hydrochloric. First of all, hydrochloric acid doesn't want to exist, okay? Like, hydrochloric acid doesn't want to exist as an acid. Chloric acid. Take a look at the electron distribution on this. Where's the electron distribution? Oh, electron density. There we go. Take a look at it. It doesn't want to exist, okay? You have a hydrogen that's barely holding on and chlorine on the other side. That's the first thing. Nitric acid. I don't know much about nitric. I have made some nitric acid in the past, but not in any quantity, only like as an experiment for explaining what acids are all about. Nitric acid. But it's a lot of oxygen for an acid. Of course I'm looking for electron density. City. I have Avogadro. I could just simulate it. The most scary thing I think I used was Perrine solution, which is a mix of sulfuric acid and hydrogen peroxide to clean lenses. I'll be honest, I didn't really have any dangerous things. I have formic acid. I do have concentrated sulfuric, I guess. The one I made. I still have it. I guess that would be like one of the most dangerous things I have. But it's semi-concentrated. It's not completely concentrated. It could be worse. Which we start with our main release. So the reduction is dioxide and water. How in depth do I want to go? Do I want to because this is basically electrolysis. It's always electrolysis. Well, it's the opposite of electrolysis. That's the point of batteries. That's a good question. To be fair, later on we do expand on them, so we can go even more in depth. Yeah. Hi there, correct. Hi, welcome. Yeah, we will. Ions aren't actually passing there, are they? It's just that the potassium hydroxide is mediating it. I fought God twice. Okay, Black Thunder, let's slow down. You didn't fight God twice. You've got beaten up twice by God, alright? I don't wanna... Let's be real. It wasn't really much of a fight. It was more like a smiting, literally. God spat on you twice. Hold on, let me collect my 3D print. If you don't mind, I'm gonna pick away at the supports of my 3D print while I think. I'm not dead though. I mean, that's quite an achievement, I guess. Yeah, I mean, this is quite an achievement. But I wouldn't chalk it up to it being a fight, you know? I feel like that's a bit much. Shucks. I hate printing with supports, you know? I really do. Because then it's really difficult to pick all of it away. I need to get myself a knife. I actually did order a precision knife for this. Should arrive in 2 days. Thank you so much, patrons. Cheers. That's neat. Now let's carry on with the animation. So operation multiplying as number was 1, then again, until we reach one where we stop. So then right here, what we do is 250. No, wait, let's do 280 actually. This will be a long one because what we'll do is we'll do this and then we will go way lower and go higher up, like so. There we go. And then what we can do is we can arrange the entire thing at the bottom and then just replace hide the time in. You're welcome. What am I welcome for? Hold on. I got distracted easily. This will go up, and then what we want is we want to copy this lower down, like so. Delete all of the keyframes. There we go. Then like this again. And then right here on the right, this will be dot dot dot. This will be 0.6. Are you working with this? Thank you, patience. Oh yeah, right. I forgot I said that. 0.8 right here. Then dot dot dot. 0.8, and then this one will be just a 1. Yeah, you see, that's the problem. It's should have been exponential. I will fix that easily. Ish. Let's do a 3. A bit of a sleight of hand. Never had anyone. Okay, so we will have it like so. Right here is where we would like the top ones to be already visible. Like so. Here we'll have them as a 1. Actually, this one will be visible a little bit further. This one will be visible a little bit beforehand. We can move it a bit. And then right here, that's where this will be visible. Right here would be a 0. Oh wait, a 1. There we go. There we go. There we go. Now for a quick sleight of hand, because I messed up with the colors, let's... Oh, this is this one, okay. Let's just keyframe all of the colors, and let's just fix them up. So right here, this one will be a little bit higher saturation, 0.75 for example, should work. I do believe, yep. This one will be 0.6, like so. And then this one also 0.75. And then we can just go higher. Perfect. Except in this case, we will have... That's a good question, actually. The ... will have to denote until we... Shucks. This is math. What do you mean with the stars? What? Why are you having this kind of reaction to math? So inside the battery, there will be a continuous electric field from potential difference. Everywhere would be a continuous electric field, as if I am not mistaken. But inside the battery, the potential would push the hydroxide into the potassium hydroxide, which would like carry it over to the other side, and then it would push electrons into the wire, which would bring them out on the other side. I mean, why do I have this kind of reaction? Can I not enjoy math? I mean, you can enjoy math, but you're not... Like, yeah, exactly. I would expect you to have this kind of reaction to chemistry, or the fact that I'm making a video about chemistry, but it kind of weakens the reaction if you already reacted to math. Because now your reaction to chemistry is kind of meaningless, considering how you don't really dabble in math, you do dabble in chemistry. It like lessens the impact. But yeah, in this case, what should we use instead of the numbers? Well, times 1. Wait, am I doing this correctly? Yes, because this right here, so this would be 2 times 1. Right. Like this. Yes, I am doing this correctly, because n minus 2, so that if there'll be a 4, then it'll be 4 minus 2, which would be, so let's just say the entire thing is a 4. No, wait, a 5. That would be 3 factorial, and 3 factorial is equal to 3 times 2 factorial. So a 6, yes. Making someone can have multiple interests. No, it's kind of like weakens the impact, you know? The thing is, so for example, if you have someone who calls you, I don't know, extremely good looking every single day, regardless of what you look like, then once you actually, I don't know, get a fancy suit or put on some makeup or whatever people do to look better, then if they call you really good looking, then that doesn't really leave any impact because that's just the norm. I think this is fine. I think so. Yeah, let's do it. Okay. And water. Okay. Once again, I would like a specific source just for this. Know what I meant. Ah, of manganese oxides. Is there a specific paper on this? How convenient. How in depth do we want to go? Because we can go in depth all the way. To be fair, we won't be really able to access the paper, will we? Hold on. let me message someone. Let me just quickly. Reduction of manganese oxide with methane was studied to investigate the stability of manganese oxygen storage compound. Manganese oxides are reduced by lower valence manganese oxide, producing CO2 water. Once the manganese oxide is reduced, can be regenerated. Reaction cycle. Yeah, this could be a good source, because then if we want to go more in depth into reaction, that could be great. If I say an extremely good looking regular day, and then, yeah, but if you look at, I didn't say it reduces all mining time, and I said it lessens the impact. Which it does. Because you see, then, once you get someone with a suit, you need to say extremely. You can't just say good looking. Oh my goodness, the thing I 3D printed fits perfectly. I just wanted you all to know that. I am amazing, in fact. Ho 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 ho. Let's see about the other thing. I don't need to sand it down. I know I'm not showing you what I'm working on, but at the same time I am thinking about the video and what to script next, so it's not time wasted. Yeah, this could tell us something about manganese oxides. Desensitization complements, exactly. Okay, the 3D print I did fits perfectly, but the problem is it fits too perfectly, and the artifacts that were left behind from the supports are just messing it up. Hold on, let me just. We need to remake a quick print, if you all don't mind, because it's. I've overdone it. I was too hopeful. I was way too hopeful what I did. Would you ever do a video on topology? Yes, I would, eventually. But so far I don't know enough about the topic, and it would be too much of a commitment. It would take too much of my time, and as such, I don't have any ideas for clever visualizations because, well, I don't know enough about topology. I do have one idea. I do have one idea for every now and then Reblax like goes on tangents after I ask him about stuff. And then I just, on accident, learn a bunch of things about topology. So I do already have a couple of ideas, but it's not solid enough, not concrete enough. No, it's the wrong one. Was this one? No, it was... Damn it, where did I save them? Where did I save the connector? There we go. That's where I saved it. Yup. Okay. That was just a quick print I'll need to do. Yeah, you see there are the supports, and right here not really much of a problem. But on this side, this cylinder was just too large. And then after removing the supports, there was still some artifacts at the bottom, and then because of those artifacts, it didn't fit. Alright, Jess, you mind doing a quick print for me again? I swear, this one should be the last one for today. I know you've been hard at work, but just one more time, okay? What do you think? Just one last time. Jesse? Okay, I'll take that as a yes. Make a do video on topology when Reblax has a PhD on it. Is Reblax planning on doing PhD on topology? I don't differentiate well between different divisions of math, I'll be honest. It's too abstract for me. I'm not a mathematician, I suck at mathematics. Naked, you are amazing. I know. Thank you, Moru. Are you messaging Flame? Yes, I am, in fact. My entire message was just the DOI and then the koi fingers emoji. That was my entire message. That's what we'll need for the more in-depth manganese oxide, which I guess I'll just script after the stream. And for now, we just do the basic one. The basic interaction, which is... Yeah, let's draw it out. What we have is manganese. I don't remember what... CPK coloring... Just that. CPK coloring, and then... Manganese, manganese, manganese. It's violetish, alright. Manganese dioxide. I'm assuming that's the configuration, as if anyone cares. And this. Then 2 electrons. That's the left side, and then the right side will be... what does it form? What do it form? It forms... manganese oxyhydroxides and 2... Alright, of course. So right here we get 2 of these, which escape into potassium hydroxide. And then manganese oxyhydroxide, which, if I am not mistaken, should look like... this. And that's where we get a question mark. That's where we need to check. Because the manganese oxyhydroxide apparently is a ghost that doesn't exist. I mean, right here, apparently. No, that's just 2 hydro... that's... A video machine that has a battery, a fully chemistry video. It's a video about a battery. That's it. It's about a battery. That's the point of the video. Not pure chemistry. How do you think a battery functions? It's just chemistry. That's a battery. This is just chemistry. Manganese dioxide plus water. Hold on now. 2 manganese dioxides, 2 waters, manganese oxyhydroxide. No, it is oxyhydroxide. Chemistry to explain them. It's not okay. I'm not using chemistry to explain the battery. Battery just works based on chemistry. That's it. That's all it works on. This is a battery. Well, you know, half reactions are important in this case, but that's all a battery is. Battery isn't material science, which will be the next however many videos. Okay, to be fair, the entire series will be just... What are you complaining about, Timon, actually? What do you mean, rest in peace? Hold on. What topic would you like more than explaining electrical components? But electrical components are literally just chemistry and material science. That's it. That's all they are. That is all they are. Okay, when it comes to maybe physics every now and then, but I don't even know if we'll get to physics because that's kind of irrelevant. For now, the way I plan on doing the series will be a battery. Well, actually, well, let's use a proper... A battery, then a wire, then a resistor, or a rectangle because it's easy to draw, then afterwards a diode, well, an LED, well, actually no, wait, LED before, I think that was an LED, I'm pretty certain, I don't remember, I don't know. I would need to. Tefta are still here. I think that was an LED. LED, which will be kind of dumb to put in this configuration, but I have my methods. Because then afterwards, am I doing this correctly? Is this an LED and is this a diode? Am I could also look it up instead of wasting your time, you know? Don't mind me. Then a diode, then after a diode is going to be everyone's favorite transistors, because they're just diodes. They both look the same. Okay, good. And then all of the transistors, which will take 700, I think as well, yeah, I think LED is just a diode with arrows to denote light. Electrical components symbols, if I remember correctly, because I mean this is light emitting diode. There we go. Oh, look at me, I'm so smart. Capacitor. Oh, I forgot about capacitors. Right, so it will be this, then it will be like 7 videos or so just about different kinds of transistors. Then a capacitor will also be important. And if we'll still be going, then maybe inductor and all the other ones. But those are the most important ones. Those are the ones I really want to explain. Because once I get through these, I can do electricity fun, and it's gonna be neat. I can do proper electricity. But yeah, first the battery. Yeah, Korean Kaikat LED has 2 arrows. Yes! Oh, I remembered. I can learn. These videos will be a fair bit shorter because I'll be just doing 1 part per video. So, you know, I don't want them to be too much. We just start manganese and water. Oh, right. Manganese oxyhydroxide. Timon, you like chemistry. Is this what a... Yeah, Jesse, thank you. That was really kind of you. Is this what manganese oxyhydroxide looks like? Did I get this right? This is a pretty basic IUPAC, inorganic IUPAC notation, but I don't remember it, so Timon, am I correct here? I'm not a chemist. I wouldn't know. Okay, I printed the part again. All the supports came off pretty easily, and now let's see. If it fits. Oh, it fits. It fits perfectly. Hold on. I know I'm supposed to be streaming, but I'm waiting for Timon to answer my question, and I'm really excited about the doodad. So that's my excuse. Anyway, how are you all doing? How is your day going? I know that Black Thunder's day is shocking, but what about everyone else? How are you all doing on this fine day? It fits. No one will respond? No one? No? We're just gonna sit in silence? It took me a while to understand the BJTs. Oh, that was the name of the other ones. I always forget the name of the other ones. But MOSFETs were easier. I actually find it the only way. Fudge, I'm sorry. I'm really kind of confused. I actually find it the other way, in my personal opinion, unholy thinkable. In my opinion, MOSFETs are the more confusing ones. Because BJTs are just 2 diodes. Like, when it comes to usage, MOSFETs are much easier. I do agree with you there. That's why I only use MOSFETs, because the BJTs are just confusing. They're dark magic when it comes to their usage. They're used, like, in mathematics of electronics, or mathematics of electricity, and it's just wild. Current versus voltage, correct? Yes, I do believe so. Because MOSFETs are metal oxide field effect semiconductors. And so they work based on the field. BJTs, however, are two diodes, and I don't remember how they work. I don't remember the inner workings exactly. And came back to hear you talk about superconductor. Not superconductors, only semiconductors. The opposite. They're not better at conducting than conductors. They are, in fact, less conductive than conductors. Well, in a way, I suppose. What's neat about semiconductors is that they really are just chemistry and material science. Oh, damn it, this screw is too short. And the longest screw, there we go. You'll do just fine. Once again, I'm sorry that I don't show you what I'm doing, but it's a Patreon-only secret, and at the same time, I am just really excited to finish it, so... Well, finish it in quotes. It's not gonna be finished for a really long time. I'm just adding the additional piece was missing. Oh, I am amazing. I'm amazing. Anyway, back to the video. Where's my phone? Oh, there it is. Right, it's on my old computer. What does it mean? That was shocking. Did you Angus again or something? BJT literally are two diodes from the PNP or NPN junctions. Yeah, as I said, they're just two diodes. With different dopings, if I remember correctly. It's like, it's the weak doped, strong dope, and medium doped. As if I remember it correctly. Oh my goodness. Timon, Tefta, Black Thunder, and anyone else who has access to the Patreon channel, I would like you all to witness the glory of my creation. There we go. I think it is absolutely beautiful. And as such, I deem it to be so. It is a bit shaky, but that's mainly because it's a prototype. But yeah, I am glorious, I know. Ah, my ego is phenomenal. Okay, first the reaction, which is have manganese dioxide. And the compound, so nothing connects to manganese, but the two oxygen is definitely not connected. That would be a very different substance. Okay, wait, so it's actually... First of all, it's ionic? How do you know it's ionic? MN OH? I have so many questions. It would be much easier if I could find this. Find this chemical. Appendage 7th grade, I think. Wait, you talk about this chemical in 7th grade? Metal plus non-metal equals ionic. Really? I had no idea it was a thing. I don't know, I didn't pay attention in my 7th grade. Hold on. First lesson 7th grade. I don't know, I didn't pay attention. I'm self-taught when it comes to chemistry, and so taught badly. What we're looking for is... Oxygen Excel. It really sucks that I can't find this chemical anywhere. It's the same post, so let's see it. Found this very strong level of manganese oxide hydroxide. Some sites it's which was correct. First, difference of substance and the oxidation number of manganese. In MMOH, the oxidation number of manganese is 3. Oh, not the oxidation numbers. I hate those. I mean, manganese oxide hydroxides, manganese. Move the element around, you will get structure. For the question regarding the structure was answers. Manganese is single bonded with OH, and manganese is double bonded with oxygen. Send me the article. Here it is. Here is the article. How about the... Manganese-free oxyhydroxide. I do believe that's the one we're looking for, but let's check. Manganese oxide free? That's just no, because it doesn't have hydrogen. Give me the hydrogen. Yes. No. No, oxyhydroxides. I'm losing my mind. I'm losing my mind. Trivalent manganese is in promoting sulfate radical-based advanced oxidation processes. I'm losing my mind. There we go. Introduction. Okay, cool. Okay. That's all different. I'm fine. The structure and position of red, blue, and white balls represent oxygen. Okay, so we have A, B, and C. A, B, C. Okay, the only difference is the orientation, which, albeit we don't care much about. I hope. Okay, so image B, this one. This would mean when it's connected, that doesn't really help, does it? I'm fine. Hold on. Let's just alkaline. alkaline battery reaction. Reduction, to be more specific. That's the part we are interested in. Dynamic science. Color me intrigued. No. LibreText! Oh, my beloved. Why didn't I think of that? It's been a while since I researched something. I should have led with LibreText. Dry cell. 2 manganese dioxides, right. It goes in the same fashion? No, it doesn't. Not quite the one we're looking for, not quite the one we're looking for either. Nickel cadmium. NiCad, that's the off-brand KiCad software. Not looking for nickel cadmium. Could we have manganese, please? It's going over a lot of different batteries actually. A comical amount considering that there isn't the manganese oxide one. Primary source research make it. I would if I could find the primary sources, Ninja. We're getting there, all right? Just let me find them first. Because let me tell you, this is not a good primary source. Considering how technically it includes the molecule I'm looking for, but technically they're focusing on a different thing. So I can't really quite use it. Ah, shucks. I keep looking up the same thing. I don't need manganese oxyhydroxide. The textbooks should have references. They would if this one even mentioned manganese dioxide, which it does not. But, fair point, manganese dioxide, alkaline battery, LibreText. I could do something else as well. That would be a bit... I don't know how stressful of you it would be. But for curiosity's sake... I am curious at this point. Would you happen to have manganese? There you are. Oh, can it break bonds in... I think it can. I won't use this as my... Oh, it just filled in the... Okay, you shouldn't be there. Actually, no. That hydrogen should not be there, in fact. How do I remove thing? How do I remove the stuff, the thing, the... Remove. No, wait, that's not what I meant. I meant it crashed. Okay. I was just curious, but fine. This is almost good, but this is using nitrogen, not potassium hydroxide. Lead storage batteries, all the batteries. Cadmium fuel cells, no. Electrolysis. Polymer composite. Go for real now. Alright, bye Black Thunder, bye. See ya. Alright. Wait! Hold on. This seems even more specific. That's good. Pardon me. Two hydrogens. Two hydrogens. One, two, three, four. 1, 2, 3, 4. When you double it, so in this case we're doing this. Oh, because for full discharge, I'm an idiot. I didn't read ahead. I have a habit of not reading ahead. This is not it either. Overall, for full discharge, well, I'll be damned. I don't know why I didn't go here sooner, honestly. It seems like a pretty fair bet. After missing it with Libertex, I should have gone here. That's a couple minutes wasted, but I haven't. Dissolving manganese compound acid to produce a solution of manganese ions. If the starting material is manganese dioxide ore, the OS is reduced to manganese oxide, then dissolved in sulfuric acid to produce manganese sulfate solution. The solution is treated to remove various harmful impurities, then used into a playing cell electrolyte in an anode typically made of graphite and titanium according to reaction. Okay. Neat. At the same time, hydrogen is generated at the cathode, which may be made of copper, graphite, or lead. Hold on, one quick thing. What's a manganese of 4? Okay, good. This, right? This one, yeah. For conductive carbons using the cathode provide electron conductivity. Carbons usually from graphite, although so yeah. Okay, neat. Now next page. Some pages are omitted. Is it the last one? Yeah, of course they are the last one. The borrowing, I don't get the borrowing aspect of this. You just log in, that's it. Yeah, I have an account. I can just log in and click borrow and that's it. It just works. What's the point? Borrow. What's the point of borrowing an online fucking textbook? I don't understand. Zinc powder. Is that even something that will help us? Yes, it is. Okay, good. Active dioxide cell actually produce manganese dioxide. Natural because high manganese content. The electrolyte is concentrated, usually potassium hydroxide, in the range of 35–50%, which affords greater conductivity and reduced hydrogen gassing rate compared to the acidic. Okay. Flip right. On discharge, the manganese dioxide cathode undergoes at first a 1 electron reduction to the oxyhydroxide. Okay. Product forms a solid solution of the reactant, giving rise to the characteristic sloping discharge curve. Are the many structural forms exist? They come from. They can't expand 70% volume. Undesirable chemical reaction as well. Independent zinc. The clear soluble conform adult electroactive discharge has the solid creases. I hope you're all enjoying the make it ASMR of murmuring.
It's not too bad.
Hi, the Theft. How you doing? Even though I asked you a second ago.
I'm actually designing a really tedious PCB and listening to you.
And you mean the one you sent the contributor channel? The unreasonable amount of switches.
50 sensors within 0.2 millimeters. Yeah.
My goodness.
By hand. But I'm done.
That's neat. What am I up to? I'm trying to... Yeah, I'm trying to figure out what the structure of manganese oxyhydroxide. The problem being that apparently no one on the internet even believes that that molecule exists except for a book.
Oh, what about Wolfram Alpha? Do they have any chemistry tools?
I am so glad you joined in.
Wolfram Alpha usually does weird stuff like that.
I think Wolfram Alpha has chemistry. Chemistry. Molecules, and then... I am so glad you joined in.
Sometimes I'm helpful.
This is... Hold on this website, turned off, there we go. Mass fraction, wait, only basic? No, please, just a little bit further, just show me the structure, or the name at the very least. Well, the name is manganese oxyhydroxide, I imagine, but that's... Doesn't really not have anything except for the IUPAC name.
What's the symbol there? It's a MNOH?
MNOOH, yes. You know, it has to be MNOH. I'm curious, sulfuric acid. Okay, with sulfuric acid it does give a 3D structure. So do we just not know what manganese oxyhydroxide looks like? We just do not...
That could be.
It's fine. It's highly unlikely. That's the problem. That's because manganese oxyhydroxide is small enough. Well, it could be a crystal. No, Wolfram Alpha would show a crystal structure, wouldn't it? This makes me less hopeful now, honestly. Wait, where's the text? There it is. And discharge to the surface, such condition, high rate discharge, low temperature factors and stability. Okay, so this is the full reaction. But this is a good source. At least we found a good source for the video, so... That's because now we can get the cathode and the anode. I mean the reduction oxidation, because that's what we're interested in more. Lecture produced, right. Okay.
So you want to try to visualize it, what the actual chemical would look like?
Yeah, because, well, that's how I always make chemistry animations, because that makes everything so much clearer. Instead of having some text on the left, some text on the right, you have the actual balls moving around and you can see where each one is going. But in this case, I'll just need to make an artistic interpretation. I'll just need to add an asterisk. Just that manganese oxyhydroxide could look different.
Yeah, you could be the first person to ever publish what it looks like.
The actual shape doesn't really matter in this case. I just didn't want to mislead anyone. But if the shape is this obscure and absolutely no one cares, it is also possible that the shape truly is irrelevant for some wacky reasons. A simple forms of solid solution with the reactant giving rise to the characteristic sloping discharge curve. Hey, bright side. This looks like a phenomenal source. So I'm including that into my sources part.
Wow, this is a tough problem. To try to actually find the layout of a chemical.
Normally it isn't. That's what's so weird about this. So normally you can just bring any kind of combination, like for example Wolfram Alpha, which once again that's actually was genuinely genius. Just a recommendation. I can do, for example, yeah, let's go with the classic. H4 for example. Wait, no. I'm having, my brain isn't braining anymore. H2SO4. Like it would give structure.
Yeah. So I'm looking online and there's programs to visualize, and it looks like this is a crystal.
Yes.
So Vesta, I'm looking it up to see if I can enter.
I mean, I have Avogadro, which should be capable, I do believe, if I use it right. Hi there, Artistic Panzer. We're going on tangents, if I'm to be completely honest. Oh, one thing which I think is especially fun about this, the reason why I'm going with manganese, by the way, because there are so many battery types I could use. The reason why I went with manganese is specifically because I wanted to make this battery before learning that both manganese dioxide and zinc are neurotoxins.
Oh.
So, yeah, I don't think I'll be making the battery.
No, I've heard horror stories of people.
Yeah,
One of my business partner's science teacher, they like made their own clothes, and because they definitely had like mercury poisoning.
I remember.
And yeah, super interesting stuff.
No, I mean, do go on. I just said I remember because it came in my head, but...
So the story is that he was just super eccentric, and I can't remember if this was high school or college, but everyone knew he just kind of went literally mad from the chemicals he handled, and his clothes were like tattered rags that are like stitched together. So he described it, and everyone's like, kind of like the Emperor's New Clothes type situation. So yeah, neurotoxin's bad. Okay, I downloaded Vesta. For some reason now I'm on the same sign tangent. I want to visualize this.
No, now I'm distracting you. This is not how the live streams usually should go. Usually it's supposed to go the other way.
I did finish though, so I have the layout.
Oh wait, hold on. One thing that's fun actually. Let me do the professional make it live stream moment. There we go. That was a bit quiet. So there we go. Now TF should be louder, and let's do the professional make it stream thing. Well, professional-ish. We don't have a budget for lights because electricity is expensive nowadays. But basically, yeah. Okay, this is a bit dark even for my lighting. Let me open that.
Oh, awesome! I like the glowy keyboard though.
There we go. It's bright
That's a good
outside.
camera.
It's 6 in the morning. But what I want to show is this right here. This PCB. I got it to work, which, considering my
yeah.
it's a MOSFET. Considering my history with MOSFETs, is honestly impressive that it works. But I actually gave up with these. I do not know how they work. I cannot find a single piece of data, a single
Yeah.
spreadsheet, a single data sheet, anything. So I just gave up on them. Now I just have like 20 of these modules lying in boxes, completely useless to me because I can't use them. And instead just made this. Which, funny enough, I made it actually on the better voice channel on Discord. I just joined the voice channel, fully expecting it to take me like 3 hours troubleshooting, but I just did it on the first try. It worked. It's a MOSFET that actually controls flow of electricity. It worked on the first try. It's just a MOSFET with a resistor connecting the gate to the source, if I'm not mistaken.
Yes.
And that's it. It just works. And I'm honestly, it feels weird to do something with a MOSFET and have it work on the first try. Also, the comical amount of plastic in the background from all the do that versions.
Yes, I know that feeling all too well.
All of these, I won't throw it away because I'm a hoarder, but all of these are useless because all of these were wrong in some way. So these are all, you can see like so many iterations of the same exact part. I'm certain
And
there's
what's
more.
again? I'm sorry, I forgot.
What is this for?
Oh, you can't say. Never mind.
Yeah, I can't say, but the most recent picture should actually explain what it's for, because I feel like it's pretty easy to guess what it's for from the newest picture. Relatively, I would say.
Yes.
I can just type in. I don't want to say it on stream because I want it to be a big surprise. But yeah, it's that simple. I'm glad I'm finally taking my time with things. My goodness. I'm proud of it, even though it's like 1/7 of the finished thing. I'm proud of it.
That's awesome. There's just so much joy in actually designing something because it's difficult, and the more difficult it is, like the more satisfaction I think I get when I'm done.
There is this trend in the artistic community of like, it's called realizing that you have free will. I don't know if you've heard of it. It's basically when someone does art, either for a living or like as a hobby really often, and realizing you have free will is basically when artists, I absolutely love that trend. It's basically when artists who have a lot of skill, a lot of talent, honed their skills for years, realize all of a sudden that they can just actually do anything, draw anything, paint anything, make music of anything. And so they like draw something extremely silly or make music about something extremely silly. It's well, usually people post this with saying like realizing that I have a free will as an artist, to like denote the fact that when you have enough skills, you don't actually need to do anything extreme. You don't need to do anything with like high expectations, something, because the skills you will have no matter what. So you might as well do something silly, do something fun. And I really like the scientific version of this, which is in artistic communities, it's realizing that you have free will, so you can actually do anything with incredible amount of skill, something incredibly silly. And in the science version of this is realizing that you can make anything. Like taking a look at, a 3D printer and realizing that it doesn't run on magic. It runs on like very achievable components. Things that are actually doable, are actually possible to make. And and only recently, I'm getting that feeling because I finally started making things and just working with mechanics and realizing, oh my goodness, I can just automate anything I want right now. Like, it's actually hard to, obviously it will be time consuming. I'm still honing my skills, but it's hard to find things that I find impossible to automate right now.
Yeah.
I absolutely love them. This is true for voice actors too. Yeah, exactly. There's all kinds of artists. I absolutely love that trend as well. It's great. And yeah, and so this is, for example, the equivalent of you making the coffee clicker. It's a very, on paper silly, like a silly goal, but considering that you have the skills for it, you can actually do it. And incredible because of that. I absolutely love it. It's great. I hope it's gonna happen more and more often from now on.
You know, it's kind of fun because I have to make tools for myself. And so it's kind of fun to be able to design them however I want to. So I don't have very many limitations. The limitations, yeah, everything's within reach. It's hard to describe. You would think there might be an infinite learning curve in order to engineer something as complicated as, you know, I don't know, a robot that's connected to Wi-Fi. But it's, you know, bite-sized chunks. So if you learn it one at a time, in a couple of years, you can actually do quite a bit.
Yeah.
There is that saying people usually overestimate what they can do in 1 year and underestimate what they can do in 10.
I like that saying a lot. It's very accurate. I would say it's...
I think so.
I mean, obviously it doesn't have to only go for years, but it is that skills are exponential, like most things in life, where it's always the most difficult to start. Once you start. So, for example, for me with SolidWorks, when I was starting, oh my goodness, the awful robot video I made a while back ago, it was terrible. I hate it. I don't know if it's public even because I hate it so much of a burning passion. It's not my typical make it hates a video when he's finished with it. No, I hate that video specifically because it was just terrible. But then once I actually got into, I'm sorry. I mean, I'm sorry to go on a tangent, but I really do. This is a real feeling I have. I really don't like the video. I don't even know if it's public, honestly. That's how much I disliked it. But now that I actually got to SolidWorks, I'm making things I'm actually proud of. I'm happy with them.
That's awesome.
It's not even that I tolerate them. I'm actually happy with them. I feel proud to show the dude that in the video. I'm actually excited for that. Yeah. But then next
thing... it sucks too because you're your own worst critic sometimes too. Like, or at least I'm my own worst critic.
But I think that's a good trait to have. I think it's always good to be someone's worst critic. It's important not to fall into any of the spirals, either into the spiral of I'm the most amazing person ever or I'm the worst person in existence. It's important to not fall into the spirals and just oscillate between the two. Manic personalities help with that a lot. They're incredible. During the day, you just love everything. At night, the realism kicks in. What is the video called? Well, Sebas, there are 3 videos I'm working on currently. The first one is the difference between programming languages, and I also am quite happy with this video. I think this video will be fun. The second one will be about the battery, explaining a battery comically in depth. And the third one, I cannot say. Oh yeah, and another thing, the computer science series. It also feels good to finally make a series on a topic I feel really confident about. Because with chemistry, with physics, with quantum mechanics especially, and so on and so forth, I kind of learn for a video. With computer science, it's the other way around, and it's a very nice feeling.
So then you can be creative and just kind of enjoy that process, as opposed to I have to learn this and try to be creative. Maybe.
Yeah. It's kind of hard to describe, but yes, we're basically. So, for example, well, you are more familiar with just making a video based on something you did, not making something for a video, because when you make a video about anything you made. I don't want to say only Open Muscle because honestly, anything you made, because you made videos about more things than just Open Muscle. I'm sorry to always go group you like.
You're typecasting me.
Yeah, typecast. Okay. Exactly. There we go. That was the exact word I was looking for. Very descriptive. Typecasting you into Open Muscle, but it's just like a very big project, and it's convenient. The same thing as
I'm actually working on it right now as I'm listening to it. So.
Yes, accurate, I suppose.
Yes.
I want to learn programming languages other than Java. What would you recommend? Well, in this video, the thing is, my entire computer science series will circle around C, because that's the language I love the most. But I would say that there are only 3 viable choices, Sebas. If you want to code for fun, then pick C. If you want to code because you want the things that you make to be fun, then choose Python. And if you want to do web development, front-end web development, then pick JavaScript. those are the three categories. If you want to do it professionally, then I don't think you have much of a luxury of picking a language, because if you want to code professionally, then depending on what you want to work with, you will have like a standard for that thing. It's going to be either C#, Rust. Those languages are usually more industry standards. But if you want the coding process to be fun, pick C. If you want the things that you make to be fun, choose Python. And front-end web development, it's category number 3 is JavaScript. JavaScript sucks, but there is no alternative for front-end development, unfortunately. Wish there was. For backend, you no longer need PHP, you can use Python. Because Python is just so broad.
Backend? Wow. That's crazy.
My website has backend in Python.
That's impressive.
I like it a lot. It's actually really easy to set up. It's Flask. I remember it just took me 5 seconds to remember what it was called. The Python tool for website backend. I just remember that was like a fluid container. It's called Flask, and you can just run a website. Alternative to PHP, much better. C backend is better.
I mean, that could be more dangerous. I don't know which is more dangerous though. Python just seems scary because of security vulnerabilities, but
okay, so on my in my right here, I don't remember what they're called. Bookmarks. I actually have a website called PHP Sadness, which I found at one point. I don't even remember where. And right here you have how many? 52. Looking for the highest number. 54 reasons why PHP is awful.
okay.
So web development backend just is awful in general. I haven't had any problems with Python yet, because the thing is, Python on an interpreter is not run directly as text, if I remember correctly. It is, Python does its own like quick compilation thing, right? Or am I misremembering?
Yeah, I think it does. Yeah, it does compile.
That would make it. I mean, Python feels less safe, but
it does feel less safe. Yeah, that's kind of what I'm saying.
But at the same time,
it might not be.
But at the same time, I don't think.
Like in hacking, a lot of times, if someone has a Python REPL environment that you can get a hold of, you can build all of your tools to sniff the entire network. So like having Python access on a device, like a Linux device in a network, is dangerous in that regards. But if the Python is always up to date and they're patching that stuff, maybe it's less dangerous.
Yeah, I was about to say that Python is the programming language that probably the most people in the world are actively working on and using. I don't, because Python is, that's the whole point of Python. The whole point of Python is for it to be the most accessible, convenient, general purpose language in existence. So I do believe that up-to-date Python should be probably really safe. Anyone finds a bug, it's going to be instantly demolished.
It was kind of funny because everyone was on 3.10.6 for a while because all the AI tools were built on that. So like, it was kind of funny because no one wanted to update, like Stable Diffusion and things like that could only run on Python 3.10.6. So, or at least the ones that I was using.
Isn't there a kind of backwards compatibility in Python maybe, where newer Python can run run parts of it in simulated older Python?
It's kind of tough because, like, if you ever had Python trying to run the same on a PC versus a Linux device, you'll get the weird bugs that won't work. So you have to kind of figure out what those are. And yeah.
Oh yeah, I've had that problem before. Yes.
So a lot of people will do like Docker, right? So then what they do is they just have an entire like virtualization or a pipeline to actually implement it on different machines. That way you're getting like I don't know how to describe it. And that's why people use Python envelopes and other stuff when they're programming something. So like just imagine a whole bunch of those small things that are built in. Another reason why Python is can be dangerous because you can do things the wrong way, quote unquote. But
But that's the problem with every single programming language. Like, people really often worry about memory leaks in C, but I mean, that's just natural selection. Memory leaks in C aren't a bug, they're a feature. They're meant to separate the programmers who are posers from the real deal. And the real deal is obviously those who do get memory leaks. That's just necessary, that's just intended. You always need memory leaks in C, otherwise, what are you even doing?
oh yeah. Okay, I designed my circuit. That was really tedious.
I don't know, automations in KiCad? Like things to
Not for-
repeat components in some kind of way?
Unless you find one, no, because I have to place, 15 sensors in 4 rows. So you have to line them up because you have to have the symbols match the footprint.
Oh, no, okay, that checks up. But
So I wouldn't, because I have to have them all evenly spaced on the PCB. And so in order to evenly space them, I just had to make markers in square boxes.
C for embedded system is just better. Mark, you are the most C programmer of C programmers, because if there is one thing that we C programmers are better at than anything else, it's talking about using C for everything. 90% of working in C is just talking about C. But that's honestly true for any low-level programming languages. The same thing goes for Rust. There's nothing Rust programmers love more than bragging about how they use Rust. This is part of the job. Right, there we go. I will try to on my Raspberry Pi. Oh, by the way, I ordered 4 new Raspberry Pi Picos. I have a problem. I need help. This is a cry for help. I ordered 4 new ones. Raspberry Pi Pico W's for wireless things.
That's awesome.
That's a problem. I don't need them. But like,
Oh,
okay, no, I mean, I
but
do
you
need
might
them.
need them.
I do
And
need
that's
them because
why-
most of my Raspberry Pi Picos don't have the W in them. They're not wireless. But
Oh yeah, yeah.
but that honestly just sounds like an addict justifying a habit more than anything else.
I swear, it's only because.
No, I just need the wireless. I just need the wireless connection. That's all. That's the entire reason. But yeah,
I just want to ask you, wireless connection for what? What are you doing that you need it?
well, I mean, I just feel like if I have a microcontroller, then it's orders of magnitude better with wireless connection. Because honestly, I can't really think of all that many uses where I wouldn't use wireless connection. If I'm trying to automate something, if I'm trying to make, I don't know, this is hypothetical, I'm not actually going to do this, but I don't know, wireless, a coffee maker, for example, then I would rather have it be wireless than run on its own code, because just the idea of like wirelessly making coffee sounds fun.
Yeah.
I stopped focusing. Why is there
That would actually be
factorials?
really fun.
I stopped focusing. Why is there factorials on my screen? Well, it's because on this live stream we ping pong between many different topics. But that would be fun. I like the fact that everything can be so easy. If only my modules worked, then everything could be just automated. If only I could... because I could buy relays. That's the thing. I could buy relays. But relays are expensive. They're way more expensive. They're like $1 a piece. Which is a lot for a basic module. Oh, another thing I ordered because of my just retail therapy. As I was ordering the Raspberry, because the thing is, yesterday I actually ordered a bunch of electronics, like $100 worth, because well, there were a couple of things I needed, and you know how it is. Sometimes you need to round up the number in order to get a free delivery, and I just did that a bunch of times and ended up at like over $100. But There's a couple of things I needed. I got like a technical mat for video. I got some components that I needed for a controller, and so on and so forth. And one of the things I also ordered was like a pack of basic circuits. So things like timers, things like some basic FETs as well, and so on and so forth.
Yeah.
So like a pack of small integrated circuits. I think they're integrated. Actually, what's the definition of an integrated circuit?
Yeah, an IC, an integrated circuit, is anything that has even a transistor is an integrated circuit, right? It's the simplest circuit.
I suppose. Oh yeah,
I
it's
usually
just
think of it as silicon that's inside that has, bigger GPIOs or bigger pins to access.
yeah. In that case, I just got like a pack of a bunch of integrated circuits, and I'll try using that as well, mostly as a learning exercise to challenge myself. I also
Yeah,
use
those are
motor
fun.
drivers to drive relays, but motor drivers are also expensive. Wait, you use motor drivers to
Yeah,
drive relays? Why? That seems very redundant. I'm sorry. Isn't the entire point of a relay?
yeah. Relay is kind of, yeah.
But that seems quite redundant. If we're doing it that way, might as well do a MOSFET to drive the motor driver. If I was good enough, I would use BJTs to drive BJTs to turn on the flow of electricity. BJTs and MOSFETs, but transistor mathematics is really rough. One day I'll get there. One day. And I do mean it. That's why I'm starting the whole series about electricity and electronics. 3.3 volt relays. Well, wait. Aren't most microcontrollers 3.3 volts? Shouldn't all microcontrollers or most integrated circuits in general output of 3.3?
Microcontrollers, 3.3. Yeah. There's also like, I don't know, 1.5 volts, I think, too. Or I've never used that, but
It's just there to take up space. Yeah, another thing I'll have to do after the stream, because for practical videos I have my own format of practical videos, which I really like. The one I use in the controller video, which is that the first chapter is the idea, second is programming, third is electronics, and so on and so forth. And I really like it because that means after today's stream, I'm just going to take a Raspberry Pi Pico, put it on the breadboard, and do like a whole layout of all components, except instead of each component, I'll just do an LED. And that way I'll be able to write the code for the Raspberry Pi Pico perfectly without actually having to add any relays, any connectors, or anything else. Because everything will be effectively either controlled with like a binary output or PWM. And both of those I can check how they work with an LED, which means I can just code everything without actually having to make the circuit, which would be especially convenient because then the next step will be testing out all of the modules I have, all of the integrated circuits I have, and then designing the PCB, which would be fun. I keep forgetting that this will not be the first PCB I'll ever make. It's just that the first one didn't work, which fills me with hope. So far, my track record is
yeah.
0 for 1.
Well, my first few didn't work.
That gives me even less hope.
Well, it was because I just did routing, so I always made a mistake on each one because I overcomplicated it.
To be fair, I am playing on easy mode because after I'm finished with my PCB, before I actually order it, I'm just gonna ask you to take a look at it. So I will be playing on easy mode.
No, definitely do that. I actually have somebody from Samsung looked at my last one, which is kind of nice.
Yeah, that's the recommended 4 layers. You're making 4 layer PCBs. That's also madness.
Yeah, and I actually I finished the new LASK one, so this is version 3. Has a haptic feedback and an embedded IMU, in inertial mass unit, measuring unit. So inertial measuring unit. I think
Because the relays...
6-axis. I can't use the 9, but
Because the relays always draw too much current and fry my picos. And use a motor... Wait, isn't there a simpler way to fix that? Or am I right now Dunning-Krugering this?
relays. Yeah, relays would always fry because those use, like a proper relay uses electromagnet to literally switch something over.
Yeah, but
And
they fry
so-
because they draw too much current. Am I Dunning-Krugering, or couldn't that be fixed using resistors, diodes, and all capacitors? Because using
Well,
a
I don't know what the
motor...
current requirement of relays are.
Oh no, I mean like in this case, in the principle, not in any specific case, only can't you stop the... Oh no, because you... No, I am Dunning-Krugering this. Never mind, I'm Dunning-Krugering
So it
this.
says 30 milliamps and 100 milliamps. That's not too bad. So I guess
I bought them
'cause I
both
think
so
the
cheap.
Raspberry Pi could do 200.
I'm sorry, 1 cent per driver? Where are you buying them from? Pardon me? Mark, where are you buying them? Where are you buying them from? And also, in what bulk do you buy them that you can get 1 cent per driver? For goodness sake, my transistors, when I bought them in bulk, were like 50 cents per transistor. That was a MOSFET.
Yeah, so Raspberry Pi can only handle 16 milliamps, and a lot of relays want a minimum of 30. So
That makes sense.
yeah, I think you're gonna fry it if you try to send that out.
But still, that's really... My modules that don't even work and that are effectively just two MOSFETs glued together, I bought them, well, I bought 20 of them at the same time, which, to be honest, not that crazy of a bulk, but they were still like $1 a piece. Or was it 70 cents?
I just bought 500 OR switches. It's like a OR power rail for, and they had to be, I think, 2 cents each or something. Or there was something crazy low.
Oh, let me actually... turning the current flow on and off using a microcontroller. Let me actually
Okay,
look at this up
3.2 cents.
to see
They're
what
3.2
people
cents each.
are using. I'm curious. MOSFET. Wait. Really, I need to. Well, don't care about enough. MOSFET.
Yeah, I just have a whole bunch of SMD P-channel and N-channel MOSFETs. How much did I pay for?
MOSFET. This is a voltage regulator, but I could buy 50 of those actually. That's a pretty reasonable price. Free-terminal voltage regulator capable of supplying excess of 1.5 ampere of an output voltage range. Easy to use and requires only 2 extended resistors to set the output voltage. Oh. Regulator by connecting fixed resistor between just and output. Wait, no, this could work well.
How much current are you drawing?
Me?
Yeah.
Oh, nothing. I'm just looking at hypotheticals so far.
Oh, well, with that MOSFET that you have.
Oh, the most also nothing. That's also looking at
Oh,
hypotheticals.
okay, okay.
I'm not right now. I'm
Because
just
I'm looking at
I'm
Mauser, because I usually go on Mauser. That's where I get all my electronic components.
L911 OS
Or
L9.
LCST. Those are the. But Mauser is pretty good because you can find what you want most of the time. So 15.
That is a very simple component. I like it. I want it. I might buy it. I'm buying it. Sold. I'm easily pleased. I get those on AliExpress. I might get some too. If they work for you, then I'm convinced. I'm gonna get them. That is a very simple datasheet. We need more datasheets like these. Just description. That's it. Does anyone actually? I mean, okay, I assume definitely engineers actually do, but the graphs on all of those datasheets are always such a comical overkill for anything I ever need. I assume that for actual engineers who work with the integrated circuits, they're actually really useful. But there is so much data. It is a cap to the datasheet.
What, the diagrams for the example circuits you're talking about? Or
No. I'm talking about the graphs later on. That hold on, let me find some.
oh yeah,
The
those are crazy.
yeah, the overkill. That's they're
Well, I think a lot of those are
unreadable.
like, well, because sometimes you have to build a driver for a chip. So like there's the gyroscope that I'm messing with. You have to communicate it with it. So if you're building your own driver in MicroPython, having that data there is awesome. But those just show you its limitations usually with heat changes.
Yeah,
So if
exactly.
something so but if you think about it, what if I want to accurately measure the conductivity of something, but the temperature changes, but my device actually is changing temperature, so I have to compensate for that. So if you're doing anything that you're like trying to measure something accurately, you'd probably want to pay
Yeah, that's what I'm
attention to that.
saying. I'm assuming that engineers actually do use those, but that's still a lot of data.
It's insane. I have not had to use one.
Yeah, I mean, I don't see myself ever getting to a level where I would need to use one.
Yeah, because like signals processing, you might need and some other stuff. I've seen a lot the diagrams that show like the on and off bits for like how it registers communication to the device. Those are kind of cool. Where they show you like the headers of the signals being sent to it. I'm trying to see. Well, do I have an example? I do.
Why are there two positive poles of power supply? Is that the same positive input terminal input power ground power ground? I'm assuming the connection is there isn't. Oh yeah, there is. Oh, there's both going. More pins, more currents. I see. I see. Okay, that checks out then. A output, pin B output. Okay, yeah, that makes sense. This does look really useful. Thank you, Mark. I'm gonna buy some. Hold on. Where's my laptop? Ah, there it is. Right. I forgot I put it over here when I was cleaning it. I say that I'm gonna buy some, I mean it, and I mean right now, because I love retail therapy.
I hear you there, Seabass.
I'm so tired that I can barely keep my eyes open, but I refuse to go to sleep. Why do you refuse? Just let it happen, Sebas. Let it happen. And now I lost my phone. I am shaken on today's stream. I feel like it's visible. I am just shaken. I can't keep attention on anything. My goodness, we're doing chemistry, computer science, and electronics at the same time. And also assembling a mechanical component in the background as well.
That's hilarious.
I buy them in hundreds. I mean, listen, if they cost a cent per example, I can buy them in thousands. I'm fine with that as well. I feel like it would be even funny to buy them in thousands at that point. I am willing to throw away $100 just for the sheer joke in the video, honestly, of having 1,000 components. Wait, no, for a cent that would be $1 actually. But I'm assuming the cent was a hyperbole. Okay, let me see. It is the L911OS. Oh my goodness, in a week? That's going through from Asia. China, possibly. In a week. Modern logistics chains are a work of art. That's all I'm going to say. 1 cent, actually. Where are you buying it that costs 1 cent per piece? Oh, 50, this. No, that's still a couple of cents. Where are you buying for a single cent? Okay, this is pretty cheap as well. 50 per 21, so that's divide. Okay, I think I found one. That's pretty good. Ah, whatever. I'm buying right away. I do realize that I'm doing a lot of things that no one can see on this live stream, from assembling to do that up to buying motor drivers on a different PC, but I would rather not actually publicly show my debit card info. So I do apologize. I'm buying 150 of them for 20
That
bucks.
Sounds like a reasonable amount.
20 bucks. That's really good. Free shipping as well. Isn't that convenient? I think this was my account. Was it? First, do you remember me? You do. How convenient.
Because they want your money.
They can have it for 150 motor drivers. Have all the money in the world. Oh, I need a new dress, right? I've moved since the last time I've used AliExpress. I'm gonna move again. Damn. I just get one package per place of residence. That's the law. That's the rules. I'm gonna bed. Alright, good night, Sebas, good night. Okay, there we go. Got this.
And I messed up my design, so.
Oh no, what happened? How
Um,
bad?
I don't know. I designed it to be 250 millimeters long, but it's not. My math must have been wrong. It's only 112 because I forgot to add a pitch difference in between them. Oh well.
Happens, I suppose. That is a very annoying circuit to make.
Yeah. $13.5. Well, I will now go because I feel not defeated, but
Annoyed, I get it.
not at
Why
anyone but myself.
why are all of the pickup points 5 kilometers away from where I live?
That's
I
okay.
live in the center of the city. This is unreasonable. This is truly just unreasonable. Ah, yes, this one. Okay, there we go. Anyway, I have 4 pickup points in walking distance. I have like 17. They just wouldn't let me select them for some reason. No, I have way more than 17. Hold on. Also depends where you draw the walking distance. In the 100 meters or 200 meters from my apartment, I have 1, 2, 3, 4, 5, 6, 7, 8. In 200 meters from my apartment, I have around 8. I live in the center of the city. Hence why I'm moving, by the way. It's really expensive. It's... No, I can't keep this up. Okay. Anyway, I think that'll be it because we're clearly I'm too shaken today to do anything, so that would be it. I would like to say that we've done a lot, but we haven't. We got distracted. We got wildly distracted all the way through. So I'm just gonna end the stream now and just continue being distracted, but this time at least I won't be distracted from the live stream. Anyway, and for now, that'll be it. Thank you so much for watching and have a great day. Bye.